All right, so in this video, we're going to talk about measures of center. Specifically, this next set of videos is going to talk about center, location, and spread. But we're talking about center in particular. So there's a lot of different measures of center. Some are more useful than others because center is kind of a nebulous, sort of vague idea. So the mode is one can be considered a measure of center. It's the value that occurs with the greatest frequency, strictly speaking. In the histogram, we're talking about the mode being the class or the highest bar in the histogram. It's really not very useful. Likewise, the mid-range is simply the value that's halfway between the maximum and the minimum values in the data set. Also really not very useful. It is very sensitive to extreme values. So if one of your highest or lowest data values changes, that mid-range might move quite a bit. And we say when it has that property that it is not resistant. Resistant is kind of an important concept. We're going to say that a statistic is resistant if the value of the statistic changes very little, hopefully maybe not even at all, if extreme data values change. So for instance, if I draw a histogram and let's say my bottom data value is 0, let's make my math easy, and we're just going to make up a histogram here, right? And let's see, 2, 4, 6, 8, 10, 12. So let's say the lowest data value we know is 0, and let's say the highest data value we actually know is 14, right? So then the mid-range would be the average halfway between 0 and 14, which in this case is 7, right? Now, if we add, let's say we add a data value, 16, 18, 20, 22. Let's say we add a data value. Now, all of a sudden, our new mid-range is 0. Let's say our highest data value is actually 22. 0 plus 22 over 2. Now our mid-range is 11. So relative to our data values in the data set, our mid-range is changed 4 units, which is quite a large change. All right, so that's an example of something that's not resistant. So one of our two main measures of center that we will use is mean. This is usually what we mean by when we say the word average. This is what you all are familiar with. You've been doing it since elementary school. You add up all your data values and you divide by the total number of data values. That's it. It's pretty reliable, which really means in statistics that if we take lots of different samples from the same population, the averages of each of the samples tend to be pretty close to each other. We're going to talk more about that in chapter 7. Now, it's more resistant than the mid-range, so we'll write that, more resistant than mid-range, but still not very resistant, okay? Now, the fancy math for this is this part means add up all the data values. That's what this Greek letter sigma means, add up from the first to the last, and then divide by the total number of data values. So n is your sample size. And we use the symbol, I think we've talked about this before, x bar, which sometimes if I can't put the actual bar over it, I'll write x underscore bar to denote x bar. That is our statistic, that is our mean. Okay, now I'm going to pause for a minute. Okay, so our next measure of center that we're going to talk about is the median. And so sometimes it's going to be appropriate to use the mean, sometimes it's going to be more appropriate to use the median. The median is sometimes also what we refer to when we say average. It's the value that's in the middle physically when the data values are arranged in increasing order. So in other words, when we look at the median, we're going to have an equal number of data values above the median value and below the median value. This one is very resistant, and I'll show you why in a minute. To calculate it, first you're going to put your data values in order. And so let's pretend for a minute, we've got a whole bunch of people and we've got their heights. So we're going to put them in order by height. Here's my really bad stick figures. They're getting very tall. It's like, and their arms aren't moving up. It's weird. But okay, 1, 2, 3, 4, 5. Let's do 6. And let's put somebody on the small end too. There we go. All right, so we've got 7 people here. 1, 2, yep, 7. And our median is this person who is physically in the middle. They have 3 people to the right of them and 3 people to the left of them. So their height, if that's what we're looking at, is going to be our median value. Now, there's an easy way to find that. We take the sample size, we add 1, and then we divide by 2. So here we would say 7 plus 1 over 2. That is 4. That is the position number. So this guy is position 1, 2, 3, 4, 5, 6, 7. These are position numbers, not the data values. So you got to look at what data value is in position 4, because these things are in order. This will result in an actual data value when n is odd. And if it's even, you're going to get something like, 4.5, and that tells you, hey, we got to average the 4th number and the 5th number. So here's an example. We've got 10 cooktop ranges that were rated very good or excellent by Consumer Reports, and we want to find the mean and the median. Now, most of the time we're going to use GeoGebra or Minitab for this, but to get a real feel for what's going on, we're going to do it by hand a time or two. All right, so the first thing we need to do is to put our data in order, because it's not in order right now. Now, we don't really need to do this for calculating the mean, but we do need to do it for the median. So, and it's a good idea as we go through to mark off the data values so that we know we've got everything. We've got 850 and 900, and then it looks like 1,000. Then we've got 2 instances of 1050. Then we've got a 1,200, a 1,250, and a 1,400. That's everything. Okay, so the mean's pretty easy, right? X bar, so n is 10 on this one. We have 10 data values I just wrote down. Our mean, we're going to add up all the data values and divide by 10. So I'm going to pull GeoGebra down here. So this is going to be my little calculator. So we could say 565 plus 750 plus 850 plus 900 plus 1,000 plus 1050, 1050 again, 1,200, 1,250, and 1,400. And then we can take that and divide by 10, so 1,000 or 10,015 divided by 10. Of course, we're going to get 1,001.5. So I'm going to move that back out. All right, 1,001.5, and of course that's dollars. Okay, so now the median, so that's our mean. For the median, remember your first step is to, if the data values are not already in order, put your data values in order. And then 2, we're going to find our place number. So n plus 1 over 2. So this is going to be 10 plus 1 over 2. That's going to give me 11 over 2, which is 5.5. Now that means, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are our place values. So our median is halfway between 1,000 and 1,050. So you can average those two out, or you can just say, hey, I know that that's 1025. Okay, so now what happens if that most expensive is 2,100 instead? Right, so we change this to 2,100. So let me pull GeoGebra back down. So what I'm going to do is I'm going to go here And I'm going to change that 1400 to a 2100. Oops, there we go. So now our total of all the data values is 10,715. We're going to divide that by 10, and our average price has gone up to 1,071.5. Now, our median, what is that going to end up being? Well, our place, we still have 10 data values. It's still place number 5.5, so halfway between 5 and 6, which means that we're halfway between 1,000 and 1050, which means our median is 1025 still. All right, so this shows us that the median is very resistant. It's kind of like not giving in to peer pressure. You know, you got that $2,100 stove saying, come on, come up here. And the median's taking a few steps to go over to that that higher data value, right? But the median is saying, I know I'm staying right where I am. So the median is very resistant, does not change much, if any, when your extreme data values change. Okay, so that's a good place maybe to stop because we're at 11 minutes.